Just in case that anyone doesn't have it yet, here's the link for today's laboratory. And once we hit the 35-minute mark, we will begin. Okay, then. So to start, in the previous modules, you've been introduced to pandas and Seaborn. And at some point, you'll probably want to share those exported data frames and figures with your colleagues. The most organized and transparent way to do this is through GitHub, which is hosted online and will host your entire project as well as previous versions of your project. Together, it's called a repository or a repo for short on GitHub. As the name suggests, GitHub is a hub for projects managed with Git, which is a program used to record all changes made to a project as a comprehensive history. And so before we talk about GitHub, let's first talk about Git. So Git has multiple subcommands, and Git itself is a Unix command line program that, like the command line programs we ran before in modules 1 and 2, needs to be run within a code block that has this bash header in order to run it within a bash shell. If you just type Git, you'll get a help message that lists the many subcommands of Git. So the reason they're called subcommands is because each of them is their own command with their own different command line options and arguments that go along with them. And as you can see here, they each do a different thing too. I'm sure you're introduced to a bunch of them in the lecture. So, before, or rather to get ready to run in Google Colab, let's do a few things. First, let's clear out the current directory, the default content folder. And you can do this with the remove command with the R recursive option. And then as an argument, you'll put the name sample data, because if you remember by default, by default, the Google Colab comes with the sample data directory with a bunch of stuff, and we don't need that. So I just forgot to split my screen. Share. And then delete all this. Okay. So as you see here, upon restarting this notebook, there's the sample data folder, which you all have probably seen before. Then, okay. So commands here. Just gonna run git here to show you that it produces the same output. And here, we also have the sample data folder. And we can remove this with this command. So remove removes files, and then with the R option, as was described before, we can remove directories with that. Next, we want to create a file called a git ignore file to ignore a hidden folder called config. This is also part of Google Collaboratory. And what the config file holds is some information to keep the settings of your Google Colab notebook stored. And we don't want to include that in our project. So we will create this git ignore file, which essentially will tell Git to ignore any hidden files, including this config directory. So next, before we start using Git, we need to set our own personal information. And the reason for this is because Git is often used to collaborate with multiple individuals. And whenever someone makes a change to the project, Git wants to know who made the change, as I'm sure everyone involved in the project does too. And the standard way to do this is by specifying your email and your name with this git config subcommand and these options. So global and then either user.email or user.name. The order doesn't matter. You can do it like this or like this, as long as you have both of them set. So in this case, we have just a dummy name. I'll put mine here. And you can run that, and there it's set. It doesn't give any output, but as long as you have the check mark, then you know it's good. Okay, so now we want to create this folder that we're in, which currently is completely empty, except for some hidden folders, like config. And we want to turn this into a Git repository. And we do that with this git init command, or subcommand. And we just type that and press enter, or the play button. And what this did is that it created another hidden folder called .git. And in this folder, it stores all the information about our repository, like all the previous versions, any comments, or basically everything that Git does behind the scenes is stored in this folder. And we can confirm that this happens with the list command with the -a option or all option. And what this outputs is everything currently in the folder, which is now a Git repository. So we have dot, which just represents the current directory. We have double dot, which represents the parent directory. So as you might recall, this content folder is a subdirectory of the root folder. You can see here, this is root, and then there's content. Next, we have this hidden config folder, and then we have this hidden Git folder, and then also the hidden git ignore file that we created earlier. The reason why these three things are hidden is because they're important for, well, the first one's important for keeping the notebook running properly, and then the other two are important for making sure your Git repository works properly. So you don't want to mess with those or accidentally delete them, because, for example, if you delete your .git folder, then you'll lose all of your history, past history for your repository, and that's not good. So moving on.
Which folder?
Oh.
If you lose which folder, you lose everything?
This .git folder.
Okay.
Yes. This is also the folder that if you see it in any directory then you know that folder is a Git repository, whether you made that directory yourself or someone else did. Like you're logging on to a shared university computer and let's say you find this folder, then you know that someone made that folder a Git repository.
Yeah, and also ls, I think you said, but I didn't quite get. Ls means list everything, right? But LSA, what was A standing for?
So this A option is short for all.
Oh, okay.
All in this case refers to how by default lists will only list the typical visual files, whereas if you list all, then it'll list the regular files and the hidden files.
Okay, thanks.
Yeah, happy to help. Okay, so continuing on, you can imagine this Git repository now as like this green dot here, which is our first node. And then as we make changes to this repository and then save those changes, we will gain new nodes. You might have done something like this with your own files, but in a different way, where let's say you have your first version of the file named like manuscript, and then you make changes to that, you call it manuscript 2, then you make changes to that in manuscript 3, and then maybe you think, okay, this is going to be the final version, and you call it manuscript final. But then it turns out not to be the final version. And then you have another version after that with more changes that it's also not the final version. So, but now it's kind of messy because you have manuscript final, and who knows if more changes need to be made after that. And so the clever thing Git does, which makes it very clean, is that it only saves the latest version. And so you don't have to come up with weird names either, because it'll just be manuscript dot whatever in this case. And however, it saves the changes that you've made previously. So if you ever want to revert back to a previous version of, in this case, your manuscript document, you can do that through Git subcommands. So yeah. Another thing to note is that notice that these are discrete nodes along this axis, and that Git does not save every single little change as in real time. Instead, you have to save and then commit those changes to create specific versions. Similar also to this analogy where you save distinct versions of this manuscript under different files. It also saves memory too when you use Git, because here you have multiple versions of the same file, which are mostly the same, whereas Git is a bit smarter and won't save exact copies of all the files. It'll only save the changes in between those files. Anyways, let's start doing this with Git. So to start, we'll make a change and we'll create a random file, and it's called textfile.txt. And as you've seen before, we use cat and then this redirection operator so that everything beneath this line gets saved within this file called textfile.txt. And here in our file, we have some sentences where it says this is a text file and has the .fasta extension. That might not seem right to you right now, but we'll fix that later. Anyways, we can run this and confirm that that's indeed what is stored in the text file by using good old cat command. And there we go. So from here, too much. Okay, so from here, we want to add this file to what's called a staging area. And how Git works is that you can make changes in your working directory. So like here, we have this text file, but before you save them as certain versions, you'll first put them in the staging area. And then once you're happy with everything in the staging area, you will commit it, commit your changes as a new version of the file. And essentially creating a new node here. And the reason the staging area exists is because if it didn't exist, then it would be possible to create lots of maybe nodes that you don't want, and it would be kind of a mess to clean that up. So by putting everything in the staging area first, then you can see, okay, this is what I want, and this is what I want to save as the new version. That's especially important when you're making a lot of changes at once. For example, let's say you have like 20 different files, and you make changes to all of them. Some of them you move, some of them you remove, some of them you're adding new files. It can be a lot to keep track of. And so you want to double check that first in the staging area before you commit to those changes. In any case, to move the files in the working directory to the staging area, we use the git add subcommand. And then to commit them to the repository, we use the git commit subcommand. So let's now add this text file that we've made with the git add command. We'll also add this additional option, -A or all, or you can also use this third version, no ignore removal. They all do the same thing. And what this will do is that it simplifies some of the Git process. I'm not sure if you were introduced into in the lectures, but there's also a subcommand called git remove. But if you just use git add and then /a, then you don't have to use git remove because it will already track any deleted files. But anyways, let's now add this to our staging area. It doesn't give any output. So if you want to double check yourself, you can use this git diff for git difference command. And now we can see that, okay, we have this text file.txt. You can also remove that, I believe. And then it gives a bit more information, but for simplicity and readability, you'll want this name only argument or option. Okay, so now that we have this file in our staging area and we're happy with it, let's move it to, let's commit it as a new version. So when you commit a file as a new version, you'll use the git commit subcommand, and then it's best practice to include a message as well with this -m option. In this case, it says added a text file because the point of the message is to describe what the change was. This is useful because if you have, let's say, a lot of changes over time, like here it only shows a few, but let's say you have like 50 or more, then you can look back at your history and say, okay, this version has this change, then this version has this other change, then this version has a different change. And so it helps to keep things organized. And again, if you're working with other people, they might not know what you saved as a new version. And so this tells them what the new version is all about. So running this, it will output some information. So one file changed, and that's our text file. And it says there's like text added to it, and yeah, it's committed. So that congrats. That's our first commit for this repository. However, as I mentioned earlier, there's actually something a bit wrong with our text file. As you noticed, it says .fast extension but the text file actually ends in .text. So we can use the Unix commands that we've learned before to change the contents of this file. And instead of .fasta, we will change it to .text. As a reminder, this redirection operator will overwrite anything that's in this file. So we just, by pressing play there, we just replaced everything in that file with this now, the correct version. So next we'll use git add and git commit again. And oh, okay. Let me fix that. And we will run git add and git commit and have a new message this time that said fix the extension error in text file.txt. Then upon running this, it says it noticed that we changed the text file and that we added some text, and then we also removed some text. So that's how Git works. You can use it on your local computer just like this, and you'll have a history of all your files and don't have to mess around with naming schemes and having a whole bunch of copies and this general disorganizedness. That said, you'll also want to often share this with other people, especially if you want other people to make changes to your project, not just yourself. And so we'll do this by moving to GitHub. So as mentioned before, GitHub is an online version, online hosting website for Git repositories. And so to get this set up, we first need to create an account. So, you can copy this text. Keeps on sending me to my homepage because I'm already logged in, but if you aren't logged in, then it'll take you to this fancy page, and you just fill in the prompts, put in your email, like blah, 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 and ask for your name and passwords and stuff. Typical, just signing up for a website, basically. Okay, and then after that, you can reach your Git homepage by clicking this link, and that's where we'll start doing things. So at your homepage, oh, it's a bit squished there. At your homepage, in this left area, you'll see there's a button that says new. And you can create a new repository by clicking on this button. Then you can create a name of repository. So let's say, I'll just call it temp because I have a feeling I'll delete this to demonstrate some more stuff later on. And then you can add a description if you want, and then you can decide whether it's public or private. For example, if you have some data that you don't want to share with the rest of the world yet, you'll make this private. And then there's some options down here, but for now, we don't need to mess with them. And with that, we've set up everything and can click Create Repository to create a repository. After that, we'll get this screen, and this is an empty repository, so there's nothing in it at the moment. And so in order to fill it with something, we can either just create a repository from scratch with these commands, but we just showed you how to make a repository within the Google Colab notebook. So instead, we'll use this code right here and copy it by clicking this copy button. So we will try to do this, but as you'll see, it causes some problems. So this goes around showing what to click, and yeah, you'll get this error. It says host key verification failed. And essentially what this says is that GitHub, Google Colab is trying to contact GitHub and say, hey, I want to change this repository. But then GitHub doesn't know whether who's running this Google Notebook. So for security reasons, it denies those changes. After all, you don't want just anyone to edit your repositories. So you only want yourself and any trusted people to do that. So a simple way to essentially get access to your account from Google Colab Notebooks is with SSH keys. SSH being short for secure shell, like as in bash shell. So at the start, and in this state, your GitHub account is kind of like a locked door without any keyholes. You can't really get in without breaking down the door, and that's not easy. And obviously, we don't want to break into GitHub. So in order to access the contents of your account, you want to essentially create a keyhole of sorts. And then also to create a key that you can put into that keyhole and unlock it with, and that only you have that key. And if in official terms, this keyhole is called a public SSH key, and the key that you put into it is called the private SSH key. But for simplicity, you can think of them as keyholes and keys. So there's a lot of commands here that to describe them in full would be outside the scope of this course, but you can essentially copy the commands here. Run them in your own notebook and run that, and then run this. And this now generated the private key, which is stored in the notebook now, specifically as a file in the hidden SSH directory, and the file itself is called ID ed25519. And just this name, I guess I could say, this name is a reference to the type of encryption algorithm that is used. So the way in which the security is performed to create a secret key.
Can you give us like 3 minutes to do this?
Sure thing.
Cynthia, and then afterwards you can share this key with someone else, whoever wants to amend your software, your code. This is the idea behind.
Yes. So what one thing you could do is that you could go to this location with change directory and then get this file, because the context manager, the left-hand panel doesn't show hidden files by default. So you'd have to use Unix commands, including change directory and the list all. And so technically, yes, you could get this file and then save it on your own computer, and then or give it to someone else. It's a bit hard in that sense because they'd have to make sure that they put it in the correct directory, which is this directory. And because that is where Git will look for the key. But another way to do this is just that every time, it's arguably more tedious, but it's simpler to do, which is that every time you run the notebook, you run through these commands to create the keys. And as you'll see later, there's some stuff you do on the GitHub website, specifically through this link. Through this link, where you can put in an SSH key. And so then I'm jumping a bit ahead, but you just copy this and you put it in this new SSH key. And it's just a matter of copy paste, as opposed to uploading a specific key into the correct directory, which can be a hassle, but technically both of them will work. And the former is how you'd share it with other people, because they wouldn't have access to this page where you can just add a key whenever you want. So they need a key that is kind of permanent.
So I generated a key and key hold pair, but I didn't input my email there at first, and it generated the pair. But now when I set my email, it wants to overwrite it, and it says to answer yes or no with Y or M, but I press Y and it doesn't work.
Are you sure that the command is exactly the same like this?
Yeah, but I placed my email then. First time I didn't, and it created the pair. Then I wanted to place my email there, but it says that there is already this pair. So asked me to overwrite it, but
I see.
I press yes, but it doesn't.
Same problem.
Okay. In that case, you can go to runtime and then just factory reset your runtime. That will solve the overwrite problem. But essentially, the root of the issue here is that sometimes Unix commands will ask for user input and then ask you to type something in interactively. However, Google Colab does not support that natively. So if you ever encounter a situation like that, you either have to add additional options to change it from an interactive mode to a non-interactive mode where it won't ask you to type anything. But in this case, it's already set correctly. So you can, probably the best thing to do is just to reset your notebook and rerun the command.
Yeah, thanks.
Yeah. Everyone else good so far? Okay.
Yeah.
Moving on then. So this was the private key. So think of as the physical key. And next we want to generate a keyhole for our door to access our account. Yet again, you will copy some code here and you'll get something like this with your that has the public key. This is the public key. And then you'll follow this link right here. And you should arrive at a page that looks like this. Then you will click new SSH key. And you'll paste your public key or your keyhole right here. And you can give it some name. I don't know, something like that. It might ask for your password. And once you do, it'll be added here. And just like the analogy before, this is now a keyhole in your door. So anyone who has this key can now access your repositories. Since the key is already stored in the notebook because you ran the previous commands, you're pretty much set to go at this moment. So these screenshots go over what to click, and you can test that all of this worked by running this command. It doesn't run any Git stuff, but it will tell you whether you are successfully authenticated and that your notebook can now connect to your GitHub account. I'll say you're successfully authenticated. So that's the message you get if you successfully do this. And another thing to note is that because every time you refresh the notebook, the files are that you put in, that you upload and save, or get deleted, and that includes this this private key. And so, if you're refreshing your notebook a lot for whatever reason, you will need to regenerate your private key and new public key. So every time you run this, it'll okay, we don't need that, but every time you rerun your notebook, then you'll have to regenerate these keys. And over time, you can end up accumulating quite a lot of keys, or rather keyholes in this case. And because each keyhole is essentially a way for someone to access your account, it's not really a good idea to have a whole bunch of these lingering around. Otherwise, your door will just have a whole bunch of keyholes, and that generally isn't a good idea. Like, it's okay to have a few, like maybe you want a keyhole to access for yourself. Let's say you want a keyhole for like your PI to access, another one for a different colleague to access. But if you just have the same kind of keyholes, like these keyholes that we're using just to access ourselves, then you don't want to have them accumulate. So you'll just delete them like this. Okay. Actually, let me do this. We actually still need this key. So, okay. So then after this, we should now be able to run this command earlier. And so to review before, we created an empty GitHub repository, and it looks like this because there's nothing inside of it. But now we can run this command, which we tried to run before. And once it's done and gives us a check mark, we can refresh this page, and we'll see that now it's a proper repository. Here's our text file, and inside this is a text file, and there's some text. So then that's your first GitHub repository. And yeah. Also, this does give some errors sometimes, but it's fine.
Cynthia, so just in case, for example, I want to go and edit your text file, how the procedure is going to be. So I want to go to your repository, and then I need the access to your file. So what I need an SSH public key to do this?
It depends. Currently, we're just talking about our own repositories. So if you run these commands, you'll have your own repository and your own version of this file. But later on, we'll talk about dealing with other people's repositories. And there's different ways to go about that. But yes, as a sneak peek ahead, if in some conditions you do need an SSH key for someone else's repository in order to access their stuff. But anyways, any other questions?
If I run the same without refreshing, if I run the same code from the beginning, which we made all the keys and keyholes, does it create new ones, or will it keep creating the same if you run the command again?
If you run the command, it'll create a different key.
Okay,
it's randomized every time according to this ED 25519 encryption algorithm.
And in which piece of code do I find my key again? If I created it by accident again?
This one right here, where, as you remember, the cat command will read, can be used to read a file, and the file we want to read is this .pub file, because pub in this case stands for public, and this is your public key, or in other words, the keyhole that you'll add to your GitHub account.
Mhm.
Okay, sounds like we're good.
Yeah, I'm having trouble, but
Oh.
I don't have the time for this. Yeah, I don't know. It says that this key is already added, but when I try to run the command that we copied from the GitHub, like git remote add origin to the my repository that I created, it says fatal remote origin already exists and error repository not found. But I copied it from my repository, the same code you copied.
Okay, in your own repository, do you see the text file added yet or not?
No, I do not.
Okay. So what might have happened is that you might have an old key, and that after rerunning this commands, you generated a new key. And so the thing with these keys is you always have to make sure that the key that you have in the notebook matches the key, one of the keyholes.
Yeah, I tried to add the new one, but it says it's the same one. So,
Okay.
but it's there that it's not repository not found. Please make sure you have the correct access rights and the repository exists.
Okay. Would you like to screen share for a moment?
Yeah, if you have time.
Okay.
You should give me permission.
Oh. Okay. Oh, it is set to all participants.
Okay. So it's here on the left. This is the
Okay.
get. This is the repository I created. Test tree.
Test you.
Yes.
Okay, let's see. Okay.
Here is my.
I see. I see. I know. I think I know what's up. So, click on the right screen. Do you see where it says SSH?
Not quite. Oh yeah.
Yes. Try clicking that. Okay. Yeah. Then go back to the code that you want to copy, and then that's the link you want to use.
This one?
Yes.
But isn't it the same?
It is not the same. So the HTTPS that is to the left of SSH on that screen, those are different protocols. Can I return the question? Okay, that means it's an issue with the key then.
So here's the key, right?
Yes.
So I copy it and I put it in a new SSH key, right?
Yes.
I put it. Key is already in use.
Okay. So what I think might be the issue here is that the key. Oh, okay. So see where you scrolled up a bit, or scroll up a bit on the left panel. See where instead of the pattern that was shown before, it says overwrite. that's so when you ran this command, it overwrote the your private key. So currently, your private key does not match your public keyhole.
Mm,
So in order to fix this, you'll go to runtime. Yep,
yes.
you'll reset. The important thing to learn from this is that you only want to run the keygen command and the eval command once. If you run it more than once, then it'll mess up the key that's associated with the notebook.
Okay. So I did the factory. Now if I press it will be okay.
Yes. Yep, that's the output you want.
Okay. And now this one. And I generate the key.
Yep. So then you want to add this new key.
Okay.
Yep.
And now will this will work?
Yes. Yeah, the reason why that's happening is because when you reset the notebook, the previous commands got undone. So the commands where you made the content directory Git repository have been undone.
Okay, thanks.
Yep.
Yes, excuse me, I also have some questions. It took me some time to create an account, and I'm afraid I'm left behind you.
No worries.
Yes, and that is why it's a bit difficult. I don't know what about other students. So I created my account, and I'm at the step